Hello everyone! Today we're going to talk about our virtual charge point, which is our open source project available on our GitHub repository. I'm going to demonstrate its capabilities and let you play with it yourself. Okay, first let's start with a brief introduction to the OCPP protocol itself. OCPP, Open Charge Point Protocol, is an open protocol that is used for communicating between a charging station and central backend systems. It is developed by Open Charge Alliance and is publicly available for everyone to use. Now, why do we need a virtual charge point to simulate the OCPP connection? Imagine a situation where you want to test edge case scenarios. It would be very difficult to do it with a physical hardware to simulate every possible error scenario. That's why we have developed a software component that uses the OCPP protocol and simulates all sorts of different scenarios for you to fully test your backend system. It is also very much convenient to use a software solution to do all sorts of stress and performance tests, and our virtual charge point allows you to launch hundreds or thousands of instances to really stress test your backend environment. For the demo presentation, we are also going to use our Solid Studio CPMS to connect to and discover the basic functionalities of the virtual charging point. All right, let's take a look at our OCPP virtual charge point. It is available as an open source code on our GitHub repository, so you can check it out yourself and play with it on your own. Our virtual charge point is written fully in TypeScript, and the code base is organized in a simple manner. Everything inside the source repository is all you need to understand how it works. Let's first clone the repository. Now we will proceed to install the required dependencies as mentioned in the README. Alright, now that we have everything installed, let's proceed to actually run the virtual charge point. For that, we will need three things. First is the WebSocket URL of the backend system that you want to connect to. Next is the charge point ID, which will be appended as a suffix to the WebSocket URL. And finally, if your backend system uses password authentication, it can also be provided as an environment variable. Let's put in all those variables and launch our charge point. All right, and that's pretty much it. Now our virtual charge point is up and running and connected to our backend system. Let's inspect the logs. First, we see that the open connection was established successfully. The first thing that the charge point will do is to send a boot notification message, just as a normal hardware station would do as well. Finally, after that, we see all the messages that are exchanged between the virtual charge point and the backend system when it first connects to our WebSocket instance. Now, let's inspect the backend system that we are connected to. As we can see, the charge point is available as online in our system as well. And navigating through the OCPP logs, we can also see that the same messages sent in the charge point console are also visible in our backend system. Let's try to do something fun. Let's try to simulate a charging session in progress. For that, we'll use our CPMS to start a remote session. Right, so the remote start transaction was accepted by our virtual charge point, and it will now simulate an ongoing charging session. The meter values are sent every minute and are visible in the virtual charge point logs and also in our backend system. We can inspect the ongoing session to see that the updated values are also reflected in the backend system. And of course, if we try to stop the session, it will behave as a physical station would. So the remote stop transaction was accepted, and our charge point simulated a stop transaction message as well, completing the session on the CPMS side. That was a basic charging session flow, but we can do much more with the virtual charge point. As I mentioned at the very beginning, it is also useful to simulate all different error scenarios And we can do that with an admin interface for our virtual charge point as well. We have prepared some examples in the repository that can be copied and adjusted to your own needs. Let's see how we can simulate a connector failure by sending a failed status notification from the virtual charge point. By sending the faulted command, it will be reflected in the virtual charge point communication log, and it will send a faulted status notification to the backend system. As we can see, it will be also reflected in our CPMS. We encourage you to experiment with the admin interface and try to send all different sorts of commands through the OCPP virtual charge point. Now, the project is open source, so we encourage your contributions as well. You can do that by either cloning the repository and creating a pull request yourself, or by opening an issue in our issue tracker. If you are interested in e-mobility, we also encourage you to visit our website at solidstudio.io to learn more about our e-mobility products for CPOs and EMPs.